All right, so this is class 3, and this is some bonus coverage here. This is called practice problem 2.F1. If you go towards the back of this chapter, they have some extra problems in there. So from the information that they've provided here, these two cables are tied together at C and loaded as shown. So they have a 1,600 kilogram load right there, and they're suspended. Draw the free body diagram needed to determine the tension in cables AC and BC. Well, I went ahead and I solved this whole thing, right? So I didn't just draw the FBD of this thing. So right here, let me declare what X and Y is. Oh, and I should have mentioned something in a previous video. I just remembered. No, that's not good. That's right. And I'll call this FC. I'll call this FB. And I call this FA. Sometimes I would have called that FC, and this would have been FBC. But I just decided to call it this time. I'm not always consistent. So let me call this guy beta and this guy alpha. So some of the first things that we're going to do here is figure out what beta is going to be, and that's the inverse tan of 400 divided by 960. Is that right? Yeah, 960, or 22.62 degrees. And then alpha is the inverse tan. It's class time going to come up. It's 7:11 right now, so I better hurry up. Maybe it wasn't a good idea, to do this. But anyway, that's 1100. Maybe I should quit this video right now and just get to class. So I don't want to it takes a couple minutes to get across campus, and I don't want to rush. But I started it, so let's see. FC, which we could have called weight, is going to be mg, or 1,600 times 9.81, or 15,700 newtons. So let's take the sum of the forces in the x direction, make it equal to 0, and in the x direction is going to be negative FAC sine of alpha plus FBC. Oh, I did call him that. You dummy. I'll call it FC. C. And I'll call this W. Why not? W. Why not? Okay. Times the sine of beta equals 0. And so I can see that, just similar to a previous example, we can arrange the thing like this right here. So FBC, and then plug in numbers in, we get 0.5105 FBC. So that's going to be useful to us because we can do the sum of the forces in the y direction is equal to 0. Right here, right? I like to put a little plus sign next to that. And then say, okay, we got FAC times the cosine of alpha plus FBC times the cosine of beta minus, I guess I said FW is for weight. So we stick in and we replace everything with the numbers that we have. So we have 0.5105. See where I replaced it with 1. I jumped a step. So that goes FBC, and then times the cosine of 48.89. I better get going here in a second. Plus, and I didn't eat dinner. I'm kind of hungry. Cosine of 22.62. And then minus our 15,700. And we're able to find out what FBC is 12,470 newtons. And it's a cable tension, so we'll call it that. And then we plug it back into 1, right? And so we said FAC is going to be equal to 0.5105 times 12,470 equals 6,366 newtons. So let's write down the answer as 6,370 newtons. There you go. And I got to get off to class, don't I? In another 5-minute video.